All right, so remember the table of polyatomic ions that I showed you a little bit ago? This is something that's in your book, and these are things that you're really going to want to memorize. However, you will have them available to you, but it's just you want to recognize that what you're looking at is a polyatomic ion or you're going to be overwhelmed. So I always just tell people, make some flashcards of the common polyatomic ions. And these are pretty common, and so then at least if you see them in a chemical formula, you will recognize what they are. All right, so we are going to use these polyatomic ions in some compounds for naming. All right, so let's get started. I'm going to switch over to my writing pad, and let's try this one. Okay, here we go. Sorry, I wasn't quite ready for that. All right, let's try Ca 2 plus NO3 minus. Okay, so we know that this is calcium ion, and once you start to familiarize yourself with the polyatomic ions, you'll recognize that this is nitrate. Okay, so you will put these together just like you have the other ones. You want to make sure that their charges are equal but opposite. But this nitrate is like a complete package, okay? So we can't be separating it out. All right, so I need to show that there are going to be two nitrates to balance out with that, the 2 plus charge on the calcium. And then since nitrate has a -1 charge, we need just one calcium. All right, so I'm going to say calcium, Ca. That was supposed to be a C. All right, we'll try that again. Ca. And then I need to show that there's two nitrates. I can only do that with parentheses, so NO3. And remember, when you guys are writing chemical formulas, you're not going to have the charges on them. So the name of this becomes, if you guys recall, this is calcium ion, and then you'll learn, because you're going to start memorizing these, this is nitrate ion. So we take off the word ion, and it's just calcium nitrate. All right, let's try another one. Let's try this one. Ca, we'll use calcium again, 2 plus PO4 3 minus. Okay, that is phosphate ion. So how will I make this balance? Okay, so this guy here is just one unit. It's a polyatomic ion. I need to show that there are 3 calciums, and I need to show that there are 2 phosphates. All right, so this becomes Ca, I don't know why that keeps doing that, Ca 3, and I need to show that there are 2 phosphates, so that is PO4, and show that there are 2 of them. The name of this is calcium phosphate. All right, let's try one with carbonate, and how about a transition metal? Let's think of a good one. Let's try, well, this one's kind of easy. We'll go PB 2 plus CO, oops, I don't know why it keeps making those, CO3 2 minus. Ignore these. For some reason it keeps defaulting to that. All right, so lead can be lead 2 or lead 4. That's one of your transition metals, and that's something that you're going to need to start remembering. Okay, and then this is a polyatomic ion carbonate. The charges are already equal but opposite, so this is going to be PB That's so weird. CO3. All right, so PbCO3. Ignore that that looks like a strange zero over the top of that. All right, and the name of it is, I better write it out, lead. And this is lead 2, so we need our Roman numeral 2, and then that is not supposed to be like that. There we go. Figuring it out. And then this is carbonate. All right. Good. Let's try another one. Let's go, we're going to try one that's quite interesting. All right, NH4 plus SO4 2 minus. Wow, so if you had not started recognizing your polyatomic ions, this one might be a little scary for you. But this is actually the polyatomic ion ammonium, and this is sulfate, okay? So how many ammoniums do we need to balance with this -2 charge on the sulfate? I would need 2 of those, and I need 1 sulfate. My formula becomes, and I need, since I'm showing that there are 2 ammoniums, I have to do the parentheses. NH4 and 2 of those, and then 1 sulfate, SO4, okay? And this is ammonium, IUM. This little pen is really hard to write with. Sulfate. All right. All right, that's how you deal with polyatomic ions, and also how you deal with the transition metals with polyatomic ions. And now we're going to move on, and we're going to try to go backwards. All right, what about this one here, lithium cyanide? So when you know the name, you guys can easily get to the chemical formula by determining what the ions are, all right? I know that lithium is Li plus, and I know that cyanide, this is a polyatomic ion, is Cn minus, okay? So now that I know the ions, it's very easy to come to the chemical formula. So this would become LiCN. All right, let's try another one. What about iron 3 sulfate? Okay, so we have to determine what the ions are first in order to get to the chemical formula. So iron, I know that it's iron 3 because of the Roman numeral. So that is Fe3 plus, and sulfate is SO4 2 minus. And in order to make the chemical formula, I have to make sure that my charges are balanced. So I need 2 irons, and I'm going to need 3 sulfates, and I'm going to have to show that with parentheses. So I'm going to have Fe2, and then parentheses SO4 3. That is a 4. Hard to tell. All right, let's try another one. All right, let's try copper 2 acetate. All right, so if you guys go back to your PowerPoint, you guys will see that acetate is this guy here. It's one of your polyatomic ions, C2H3O2 minus. All right, so we're going to look at our ions. Copper, we know is copper 2. Copper can be copper 1 or copper 2. Cu, 2 plus, and then remembering what that is there, C2H3O2 minus. All right, so if you guys did not recognize that this was a polyatomic ion, it might look a little bit scary. But once you kind of get to know those, you're like, oh, okay, that's just acetate. All right, so these guys already balance their charges. They're already equal but opposite. So the chemical formula for copper 2 acetate is Cu C2H3O2. All right, let's just do one more. Let's try lithium nitride. All right, so let's look at the ions. Lithium we know is Li+1. Nitride we know is N3-. These are just cation and anion straight off of the periodic table. We need 3 lithiums to balance out with the nitrogen. Okay, so this becomes Li3N. All right, great. So everything that we've learned to name so far are the ions by themselves and the ionic compounds. I'm going to post another video that finishes up the naming with the molecular compounds. For acids, I'm just going to have you memorize the acids. There are rules to naming them, but they're kind of tedious. And then we just have to learn how to figure out the atomic masses of the formulas. All right, hope you enjoyed this video, and see you in the next one. Thanks.